देखो
हो गया।
ऊपर से किया
तो ग्रेड ही चलेगा आपके ऐसे ही तो होता है शायद।
देखते कि कॉपीराइट लिए ही नहीं थे ना।
जब भी कोई भारत अपनी जी ऐप से नहीं लड़ रहे होते वह और मजबूत कर रहे हैं।
उसमें तो अभी दूसरा सिम ज्वाइन कर लिया
और
95 लोग ज्वाइन किया है भी कर लिए हैं
जो हम
हट
पटना
जाएंगे
में
जहाँ
नहीं
छोड़
गए
देंगे
थे 2 साल कोरोना में, तो फीस हम नहीं जमा करते।
Good evening, everyone. This is Sharanya Mitra from Firalal Public School. On behalf of our principal, Mr. Neeraj Kumar Sinha, I would like to highlight some important points regarding the training. First, certificate will be issued to only those who will score 60% or above. Second, all the Ranchi Sahodya School Complex in charges or principals are supposed to submit the trainee's name 3 hours before the training begins. None of the participants are requested to share the attendance link. Fourth, those whose name will not be there in the list provided by the school will not get the certificate even if they attend the training. Thank you. Now, I would like to welcome Miss Sandhya Kiran. Ma'am, are you there? Sandhya ma'am, are you there? Ma'am, you can unmute yourself. I have done all the things.
Good evening, all of you. Sorry for the inconvenience. Network. Again, good evening, everyone, and welcome to my presentation. First of all, let me thank you all for coming here today. So here, my topic today we are going to discuss about this, a friendly introduction to number theory. Let me start by saying a few words about my own background. I am Sandhya Kiran, TGT Maths from Sir Lavirla Public School, Ranchi. As you can see on the screen, our topic today is a friendly introduction to number theory. Whenever we talk about numbers and its expressions, immediately number system comes to our mind. So in number system, we are going to discuss our objectives are to determine the divisibility of integers, to determine the prime factorization of an integer, find the quotient and remainder from a division of integers, find the greatest common divisor of two integers, find the least common multiple of two integers, use of Euclidean algorithm, where we will know how to find it out GCD, greatest common divisor of two integers. Basically, we are going to discuss about the integers in this number system. Then apply the use of congruence and modular. Then find the smallest non-negative integer that satisfies the given system of congruence. And lastly, we will discuss about the divisibility of the numbers. How we can explain to the student and how we can express it properly to the student that they can able to do it properly. So before going to start, let's see what is the number theory. Numbers means whenever we are talking about any numbers, it comes to our mind 1, 2, 3, 4, and so on till infinity. And these all numbers, whenever we are talking and discussing, that all numbers either we can talk as if from the primary level we talk the natural number, whole number, even number, and all. Whenever we talk about numbers and its expressions, immediately numeral system comes to our mind. A mathematical notation for representing digital using digital settings or other symbols in a consistent manner. Numbers has very fascinating role in our lives. Sometimes it is examination marks. Basically, if you are going to talk about, always everyone talks about the marks, how much you have scored in boards, how much into promotion of the classes and also where the numerals comes first. And you know, sometimes it is examination marks, as I told, most important in everyone's life. All of we will discuss about this marks, wherever we are going, whether we are going to the higher education or the promotion of any class or anything. So number comes here first. As I see, sometimes election results, analysis, cricket score, but the most important one is when we are out for shopping, online and offline.
देखो
Yeah. And it is the sale, discount time, number
तुम
calculation.
दाचिपाना है हैं दाचिपाना है तो
And whenever we can find and see the little bit of maths, if I can say here that little bit of maths in everyone's life. So here we will discuss what is a number theory. Before number theory, we know that whenever we are teaching maths in the class, there we find it out fear of maths to the students. Fear of maths is very common, but being a maths teacher, it's our duty to create interest in child and how we can do so. So with this, with the help of this, whatever I have tried my best to explain here, and we can implement in the class. It is not necessary that the teacher will be math teacher only. We can discuss and correlate with other subjects also. It can be related with all the subjects. Whenever we are talking about, whenever we are teaching, on that time we can able to explain this number theory, explain the nature of numbers, and what are the numbers, which are the types of numbers, and how we can discuss in the class. So make them understand maths and they can find it out very interesting. So here, few topics based on number theory. First one, number theory, it is a collection of set of positive whole numbers, set of natural numbers that are partly experimental and partly theoretical. So objectives, what are the objectives to learn number theory? Objectives are to discover interesting and unexpected relationship between different sorts of numbers and to prove that these relationships are true. Purpose, what are the purpose? Purpose of a number is used to count, measure, and calculate, label it also. So here, if we will talk about number theory, it is a branch of pure maths devoted to the study to the natural numbers and integers. It is the study of set of positive whole numbers, which are usually called the set of natural numbers, partly experimental and partly theoretical. What is the meaning of partly experimental? Experimental means we can experiment with the numbers in different ways. If you are talking about the probability, if you are rolling a die, from there we can teach the students the even numbers, odd numbers, prime numbers, everything with a very simple examples, with a collection of sticks. If you are taking the matchstick, and that can also be we can use, or if you are taking any type of sticks, and from there we can find it out the numbers, we can arrange them properly. So experimental means the part leads to question and suggest ways to answer them. So while showing them, suppose we are rolling a die and we are getting the numbers 1, 3, 5 and so on, and this is the experimental, and we can ask the student that which type of question may arises here, what are the answers and everything. Similarly, theoretical. Theoretical means if you will talk about theoretical, it is coming the geometry part, or we can say that it tries to devise an argument which gives a conclusion answer to the question. So means this is the answer that true or false, yes or no, this type of are coming in the theoretical part. So whenever we are talking about maths, we must know that who is the father of modern number theory. So here let's discuss about little bit about the father of modern number theory. Fermat was a French mathematician who is given the credit for early development that lead to infinite calculus, including his technique of inequality. And he is often called the father of modern number theory. He was one of the most brilliant and productive mathematician of his time, making many contributions to the differential and integral calculus, number theory, optics, and analytical geometry. So he had discovered these fundamental principles of analytical geometry. So he was very much with the help, or we can say that He has done all probability theory and in correspondence with Pascal. We have done some Pascal's triangle also, which gives us how to find it out the cube, how to find it out the square of any two given numbers, and so on. Now let's come to the next mathematician, who is again a very brilliant, and you can say that we must have heard this name, Carl Friedrich Gauss. He says that he was the German mathematician. He said that mathematics is the queen of the science and number theory is the queen of mathematics. So we are going to discuss the queen of mathematics here. So here he was the physicist who made significant contributions to many fields in the arena of mathematics and sciences. He said that if one number is subtracted from another, subtracted means if the greater number we are subtracting from the smaller number, we are getting any negative number. If the smaller number is subtracted from the greater, then we are getting a whole number, a number, positive number. So from here, he has discovered the integers, positive and negative values, and that's what we will discuss later on. He also made important contribution to the number theory here, and he has discovered the triple bar system, and that triple bar system is congruence. What we are teaching, congruence, when we are comparing two triangles with the help of sides as well as with the help of angles. Next. Here, application, elementary number theory. What is elementary number theory? Elementary number theory is the branch of number theory in which elementary method, arithmetic, geometry, and high school algebra are used to solve equations with integers or rational solutions. So here we can see lots of symbols. Here we can see how the parabola is made with linear equations, how Pythagoras theorem can be generated, how we can trigonometric ratios, how we can draw the graph, and everything we can do here. You can see at the lower part of the screen there Pascal triangle is there. With the help of this, we can explain student binomial theorem, and with the help of the junior classes in the 8, 9, 10, we can teach how to get the a plus b whole square and so on. So introduction to number theory, as I told at the beginning, that we will discuss basically about the integers. Introduction to number theory. Number theory is about integers and their properties. We will start with the basic principles: divisibility, greatest common divisors, least common multiples, and modular arithmetic. GCD is what? GCD. Generally, we talk to the student for highest common factor with the help of prime numbers. Least common multiples are LCM, where also we can use the prime numbers. And modular arithmetic, here we can get the mod, means the remainder. If you are dividing two numbers, then what is the remainder? How the remainder will be positive, and so on. So I'll look at this relevant algorithms based on this. So here, the division part. In the branch of pure mathematics, here we can see A and B are integers with A not equals to 0. We say that A divides B. If there is an integer, so that B equals to AC. So what we are doing here? Here we have an integer C that is multiplied to A to get the value of B. Simple. When A divides B, we say that A is a factor of B because A divides B. So A is a factor of B and that B is a multiple of A. The notation A by B means that A divides B. This we used, and we used to say in the classes also A by B, one numerator, another one is denominator, and we are getting factors from these two terms. Next, we write A into B when A does not divide B. Means A is not divisible by B. Yeah. Next, divisibility theorem can be proved by this examples. Few examples I have taken. Here, A, B, and C are true. When? First one, A by B and A by B, A by C. Then A divides B plus C. What we have done here? We have added the denominator, and let's see whether it is applicable or not. Here one example is there, 3 by 6 and 3 by 9. Here numerator is equal. So what we are doing? We are adding the denominator and we find it out that it is divisible. B plus C is 15, 3 5s are 15. Similarly, one more example here. We have taken 5 by 10, 5 by 20. Both numerator are equal, denominator are added, and we are getting the numbers. So the third example, 4 by 8, 8 by 4, and 8 by 24. So what is coming here? 4 by 24. Why it has come? Now let's discuss about prime numbers. Here, prime numbers, whenever we are talking about prime numbers, can you share in the chat box what is the prime number?
बनेगा जब बनवाएगा.
Yes, prime numbers are the numbers which is divisible by 1 and itself. So a number which is divisible by 1 and itself, here few prime numbers are collected here. And I think we are teaching in the classes also how to find it out the prime numbers. Finding out the prime numbers, if you are writing all the numbers from 1 to 100 in a tabular form, and then we are going to cut the numbers 1 to 100 in a square box, 50 into 50 grid. And if you are going to cancel first even, then multiple of 3 and so on, then we will find it out. At the end, we are getting all the prime numbers. And for the prime numbers, we are
क्या हुआ तो
going
पानी
to
लिया.
discuss the following points. Please mute someone is unmuted. Yeah, primes hold the utmost importance to number theories because they are the building blocks of whole numbers, and important to the world because they are odd mathematical properties. Odd mathematical properties means it is divisible by the number and 1 itself. Make them perfect for our current use. The simplest primality test is trial division. What we used to do, and we used to teach to the student to find it out LCM and HCF with the help of prime factors. Here, what is the twin prime number? What is co-prime number? Smallest prime number? Why 1 is not a prime number? This all can be discussed here. We are going to discuss with this, all this. So here, first I will explain how to identify a prime number. Generally, we say to the student 1 and the number itself. So here I have taken few examples 2, 3, 5, 7, 11, 13, 17, 19, and 23. Here we can see these all numbers doesn't have any other factors rather than the number itself. So here list 2, 3, 5, 7, 11. These are the prime numbers in increasing order, and many are there. So here how to check the number? Let n be a number. We will take any number. This you can check by your own now also. If you have pen and paper, any number you can take and find the greatest integer. Let it be k among the number, and less than equals to square root of n, whatever number we have taken, and square root of it. Then we can find it out that k less than equals to root n, whatever number we have assumed, and the greatest integer in that number. Now divide the number n by all the prime numbers that are less than or equal to k. If n is divisible by any one of the prime number less than or equal to k, then n is not a prime number. Leaving 2, if you are taking 4, then we have the 2 value and it is divisible, so it is not a prime number. Exactly, we can check this one and we can discuss in the class. Only the simple thing we have to remember, k less than equals to root n, and n is the number and k is the greatest integer of that number. Next, from the prime number, we have got very interesting numbers that we can discuss in the class, and student will find interest to do so. And they will also create the numbers. They will also find out the numbers And we can discuss this twisted prime number. What is twisted prime number? A number is called a twisted prime number if it is a prime number and reverse of this number is also a prime number. Very few numbers are there which are having the same type. Here in the example I have given 2, 3, 5, 7. We don't have to do much because these are the single number. Whether we are writing from the direct or reverse, the numbers are coming as it is 2, 3, 5, 7. But 11, if you are writing, the reverse is 11. 13, we have 31. 17, we have 71. So these are the twisted prime number. Here you can see the example. I have taken 79. If you are reversing it, it comes 97. So it is a true. It is a true that it is a twisted prime number. But here we can see 43. 43 is a prime number. But if you are reversing it, it comes as 34. 34 is an even number, we know, and it is divisible. It has factors. So we say that it is not the twisted prime number. So this is very easy to remember that how we can explain to the student. Twisted prime number. Next, prime. This is what I have explained previously, that if n is a composite integer, then n has a prime divisor less than or equal to root n. This is easy to see. If n is a composite integer, it must have two prime divisors p1 and p2. So that when we are going to multiply p1 and p2, it gives us n. And p1 and p2 cannot both be greater than n. If it is greater than n, then it won't come in the primes. Division algorithm. This we explain. Whenever we are doing the division, we say few terms to the student: divisor, dividend, quotient, and remainder. So here I have written a equals to dq plus r. If you can see here, a is an integer, d is a positive integer, and r lies between 0 and less than 2, and r is the remainder. So here we can see d is the divisor, a is the dividend, q is r is the remainder. Here I have taken one example. We can it can be clear. Here you can see we have written a equals to dq plus r. Here the example.
आ गया क्या अभी तक माल नहीं आया
Yes, this is Anjali Soni. I have got a message from the host.
Yes, ma'am.
Yes, ma'am. This is Anjali, ma'am. Yeah. Ma'am, how can I help?
Ma'am, ma'am have left, I think.
Okay, somehow she has met some network issues. Just I'll let her ping in once again. Okay. By the time I'm connected over there, ma'am.
Okay.
Yes, I hope that most of us would have learned about the different techniques taught by Sandhya ma'am, the different types of division, the techniques of division. These are so many divisions that we have learned from her. So in mathematics also, we can incorporate AI for doing. There are various tools in mathematics also, which can be solved with AI components. Like for geometry and other things, there are really many more. So how many of you find mathematics interesting? I am one among them. Yes, and these small techniques taught by Sandhya ma'am, these actually help students for gaining marks. Yes, now I think Sandhya ma'am is about to end to the meeting. I'll just once again ping her up to join the meeting. There's some network glitch. Yeah, ma'am, I would request you to unmute Sandhya, ma'am. She's already in the meeting. She's muted.
Okay, ma'am.
Okay, she's already in the meeting. Thank you, ma'am.
मुस्लिम लोग का पैजामा जिसमें
Sandhya, ma'am, you can unmute yourself.
भेड़ों को समझ मिल जाती पर नहीं
डेफिनेशन लिखो
Yes, ma'am. Yes. Hello, ma'am. Miss Anjali this side.
यहाँ से याद करो
भेड़िया समझ नहीं आता
I'm audible.
अभी देखो राइट डाउन 10 number greater than 7,420 बस less than 8,000 उसको भी पढ़ो
Audible?
Yes, ma'am, you are audible.
I'm having the disturbance.
She's already in the meeting. We need to unmute her.
Ma'am, I'm trying to
भेड़िया
unmute
यार
her, but
Everyone?
She told me that she's there in the meeting. In fact, she's
yes, ma'am, she have unmuted.
थोड़ा एमडी टाइप दुपट्टा पे भी थोड़ा सा इस पे लगेगा भी तो ग्रीन दुपट्टा में तुमको ब्राउन बॉर्डर करवाना है ये अच्छा लग रहा है पहना हुआ नहीं ना रहता है बोलो तो नहीं पता चलता इसके लिए लेना है ना और भी इसका तो और भी आप इसको पीछे ला सकते हैं पहचान भी नहीं रहती कहीं तो नहीं हो जाना देखो देखो तो वो देखो वो देखो अरे इसका क्या क्या पेड़ है क्या क्या ना 23
Sandhya ma'am, kindly unmute yourself.
Yes, now it is unmuted. Yes, now it is unmuted. So we are talking about the division algorithm. And here for the negative one, we can see what happens when we divide a negative number. Here I have taken one example, minus 11 by 3. So here we have to remember that a remainder cannot be negative. So here we can see minus 11 equals to 3 into minus 4 I have written. Minus 11 is the dividend, 3 is the divisor, minus 4 is called the quotient, and 1 is called the remainder. So here we can find it out that remainder should not be equals to minus. And here greatest common divisor, as we have talked about, that whenever we are finding out the highest common factor, here we can see a and b the integers, not both 0. The largest integer d such that d divides a and d divides b is called the greatest common divisor of a and b. The greatest common divisor of a and b is denoted by GCD a comma b. What is GCD or greatest common divisor of 48 and 72? Can anyone answer in the chat box? Here we have to take the common divisors of both, and after taking the common divisors, from there we have to calculate the value. Here we can see that greatest common divisor of 48 and 72 is 24. Similarly, what is the greatest common divisor of 19 and 72? Can anyone answer this one? Please write in the chat box. 38, 1. See here, the answer is 1. We don't have any common values to find it out, the common factors. Here the common factor is 1. Thank you very much to everyone. Next, here using prime factorization. When we are using the prime factorization, this formula is applicable. P1 to the power A1, P2 to the power A2, and so on till Pn to the power An. This is the first prime factors, first factor, and for the second factor, P1, B1, P2 to the power B2, and P1 to the power Bn. How it is coming? See here. Here, we must remember that P1 should be less than P2 till Pn, and A1, B1 belongs to the natural number, and what is I? I lies between 1 and n. So whenever we are talking about the GCD, we are taking the power value that is minimum. Minimum of A1, B1, A2, B2, and An, Bn. Here, I'm giving you an example. A equals to 60, I have taken a number. What are the prime factors of this? With the help of the power. If you are taking the prime factor for 60, it is coming 2 into 2, 3, and 5. So it can be written as 2 square into 3 into 5. Similarly for 51, similarly for 54, what are the factors? This we have to see prime factors with the form of a power. So here it is coming 2 to the power 1, 3 to the power 3, and 5 to the power 0. 5 to the power 0 I have written because 5 is not there. So 2 and 3, 2 prime factors are used for 54. So now from this, we can find it out greatest common divisor of AB. So what is that? Here we can find it out 2, 3, and 5 to the power 0. That is coming as 6. So at GCD of 60 and 54 is 6. Now relatively prime integers. Relatively prime integers, here they are, when they are said or when they are called relatively prime, if their greatest common divisor is 1. When greatest common divisor, that we have done one example previously, then it is known as relatively prime integers. Here is the question. Are 15 and 28 relatively prime? Can you answer? Answer in the chat box, please. Yes, it is. Yes, it is. 15 and 21. We have only 1 as the greatest common divisor. So 1 value is there. So it is relatively prime number. Are 55 and 28 relatively prime? Here, like this type of questions we can share with the student and they can able to answer, they can calculate and they can tell it to us. Are 35 and 28 relatively prime? No, because when we are going to find it out, then we have got the answer equals to 7. So that is, it is not a relatively prime. So relatively prime can be explained as any two, if we are taking any two numbers, integers, and we are finding out greatest common divisor of it, then we are finding out that it is relatively prime. So list common multiple also. Here we know how to find it out, the LCM. Here we have taken HCF and here we will calculate for the LCM. And for LCM, the least common multiple of the positive integers A and B is the smallest positive integer that divisible by both A and B. We denote LCM. This we used to teach to the student, and for LCM, I think all of you know how to find it out LCM of any two given integers. Examples I am taking, I have taken the same example 3 and 7. If you are finding out LCM 3 and 7, we have one common factor. These are the relatively prime numbers, and here LCM will be 3 into 7, that is 21. If you are taking 4 and 6, then what will be the LCM? It is 12. How it is coming 12? Here we have the common factors 2 square and here 2 into 3. So 3 into 4 is multiplied and we have got 12. Similarly, LCM for 5 and 10. Answer is 10. So using prime factorization, how we can calculate? Exactly same whatever we have done in the previous one for greatest common divisor. Their greatest common divisor A, we have taken the value P1A1, P2A2, Pn and P1 to the power B1, P2 to the power B2, Pn to the power Bn. So here, there also P1 is the smallest one and Pn is the greater one. And AI and BI belongs to N, where I lies between 1 and N. So here 1 is included as well as N is also included. So LCM, there we have taken minimum, here we are taking power maximum. Example, the same example I have chosen, that is 60. 60 is factor, prime factors write down, and then we can from here take the maximum and we can do. For B, it is 54 factors, whatever we have done for that. The next we have to find it out, LCM of AB. That is coming 540. Here we have taken the maximum. 2 to the power 2 is the maximum, 3 cube is maximum, and 5 to the power 1 is maximum. So here we have taken these all values and we have got 540. Modular arithmetic. Modular arithmetic, here we have taken the integers, mod we have to find it out. So what is that? Let A be an integer and M be a positive integer. We denote by A mod M, the remainder when A is divided by M. Examples. Here we can see 9 mod 1. 9 mod 1 means if you are going to divide 9 with 4. 4's multiplication is 4 2's are 8 and the remainder is 1. So here for mod we will write value 1. What will be the 9 mod 3? We don't have anything. Remainder will be 0. So we are writing here. And 9 mod 10 will be? Can anyone answer? Here it is 9. And minus 13 mod 4. Can anyone write the answer? Minus 13 mod 4. it is coming 3. Here in mod, all the answers are positive. So as we have discussed, for the mathematician who invented this mod with this notation congruence, that is modulo. It is B modulo M. We say it one. And in other words, we can say A modulo M or B modulo M. When it is applicable, here M divides A minus B. It is the congruent to B modulo M. So here congruence, when we are talking about, then we can use this example, how it is coming true. 46 is congruent to 68 mod 11. How we can calculate it? We will subtract the value 46 minus 68. Since we are talking about the mod, so values will be positive always. So here we are getting 11 answer. Let's see few example. 46 is congruent 68 mod 22. Whether it is true or not, let's find it out. Yes, it is true, because it is divisible by 11 again. So for which integer z, it is true that z is modular, z is equivalent to 12 mod 10. Can it is possible? Yes. Z belongs to all the negative as well as the positive numbers. So here we are going to talk about the GCD-Z theorem. What we have learned, A equals to B plus Km. Divisor, what we have done in the previous slides. Next comes Euclidean algorithm. Euclidean algorithm, again, it is depending upon, it is on the basis of greatest common divisor. Here also we used to find it out, the 287 by 91. How it can be? 287 by 91. 91's multiple, 91 into 3 plus 14. 14 is the remainder, and we can do so. So let's divide 91 by 14 and see what is coming. So 14's how much multiple, and the remainder gives us 91. This we will explain to the student, and we can explain it how the algorithm is applicable and how greatest integer value is equal and how we can reduce and write it down, and we can explain it by this manner. So lastly, when we are 14 and 19, we are 91 when we are talking about, then we are getting the value 14 and 7. And then what is coming here? Divides 14 by 7. When we are dividing it by 14 by 7, then we are getting 0 over there. The remainder is 0. So it is totally divisible. How it is divisible? This we teach in class 10 maths. There we have the chapter where we explain this algorithms. So here finally we will get this one. So what are the facts? Facts we know. Till now we know that 1 is considered as neither a prime nor a composite number. All even numbers are composite number except 2. Any prime number greater than 3 is often written in the form of 6 and minus 1, where n is a natural number. Now we will discuss few interesting numbers. Cyclic number. You can note down this number and you can discuss with your students in the class. It doesn't matter about the only math subject. It can be used in any of the subject. Here this numbers 142857. This number it is rotating. How it is rotating? If you are going to multiply with 1, you are getting the same number. If you are multiplying with 2, the same number arranged in different way. 3 also, it is arranged in different way. You can see the multiples, or you can calculate by your own and see that whether the same number is repeating or not. Yes, the same number is repeating with the multiple of number. If you are going to look at the figure here, how it is rotating. If you are multiplied with 1, 2, 3, 4, 5 and 6. Now the next one more type of number, that is neon number. What is neon number? It is again very interesting, A neon number is a number where the sum of digits of a square of the number is equal to the number. 9. If I have taken 9, square of 9 gives us 81. 81, if you are going to add 8 plus 1, we get the number 9. So it is a neon number. But the next example, 45. If you are finding out the square of 45, it is coming 2025. If you are going to add all the number, we are getting 9. So it is not equal, so it is not a neon number. And next comes Krishnamurti number. Krishnamurti number, hope many of you will be knowing the factorials. This factorials a number we will take and factorial of all the digits and add them. Then we are getting the same number. A Krishnamurti number is the number whose sum of the factorials of digits is equal to the number itself. 145, the most common number. This is known as Krishnamurti number. Factorial of 1 plus factorial of 4 plus factorial of 5 gives us 1 plus 24 plus 120. That is 145. The same number is repeated. You can check with other numbers also. It is coming. It is very interesting. We can give the students lots of numbers and we can ask them to find it out. Next is xylem and phloem number. That listen like that we are talking about the biology, but here is again very interesting. We have to take the first and last number, add them, and the in between numbers. If both are equal, then it is xylem number. If they are not equal, then it is phloem number. See the example here. Next, here you can see 3, 4, 3, 2, 6. We have taken a number. First and last number sum gives us 3 plus 6 equals to 9. And the innermost numbers 4 plus 3 plus 2 gives us 9. So the left one is the xylem number. And for the right hand side number, you can see 173156. First and last number gives us 7. And the innermost numbers gives us 16. So it is not a xylem, it is a phloem number. Similarly, abundant number. Abundant number means the numbers where we are taking their factors and adding them. And now the adding the factors, we are getting more than that number is known as abundant number. Like 1, 2, 3, 4. Here 12 factors are 1, 2, 3, 4, 6 and 12. 12 is not included. The rest all are added. It gives us 16. If it is coming 16, means it is not a number, it is an abundant number. And palindromic number, everybody knows what is a palindrome. We were playing in the childhood also that what are the palindromic words. Exactly same, the palindromic numbers. The numbers from the left
Excuse
to
me,
right and
ma'am.
right to left. Yes.
Sorry for the interruption. Ma'am, kindly send the attendance link.
Yes, it is shared. Let's continue with the next slide. Here, after palindromic number, we have Armstrong number. Armstrong number, whatever number you have, and if you are finding out the cube of that number and adding, then we will get the same number. So this is known as Armstrong number. Like Krishnamurti number, there we are finding out the factorials. Here we will find it out the cube of the number. Next, Fibonacci images of the nature. This also we find it out. It is very interesting. and it looks very beautiful where in the flowers here we can see this type of series. And Pythagorean triplets, whenever we are talking about trigonometry and combination of three numbers, we find it out the Pythagorean triplets. Pythagorean triplets, h square equals to p square plus b square, and it takes the right angle triangle for calculation purpose. And trigonometry is the best and very interesting part of mathematics that creates interest in the students. Here we can see that how they can calculate by writing a square plus b square equals to c square, and the form where h square hypotenuse, perpendicular and base comes. Here we know that if we are adding two odd, then we get the even. Odd plus even gives us odd, and even plus even gives us even numbers. Divisibility rule, when we are dividing any numbers, how easily we can explain it to the students. If you are explaining the student divisibility rule 2, 3, 4, 5, 6, 9 and 10, then how we can do so. Here it is given how to divide and how to find it out. And for 13 also we have different types of methods. There are 3 to 4 methods. So the Ramanujan numbers. What is Ramanujan number? Without Ramanujan number, we can't complete our number theory. So 1729 is known as the Ramanujan number. Okay, thank you everybody for joining. And this is the magic number. It is here. Thank you all.